quick review on how to differentiate transformations. We'll just do a two-space example because it's the same as for n space. Two transformations, and they're composite. So I'm doing transformation S and T. T is first, S is second. And then their derivatives, just ds dt. To see this, so you take our position vector and take the partials. Those are our tangent vectors. That's our matrix. Position vector uv. Take the partials to get our tangent vectors, the columns of our matrix. Position vector xy. Take the partials, columns of the matrix. At every point in the domain, it's a different matrix, of course. Doing the matrix multiplication, every component is our chain rule. So this is how differentiation of transformations works. Let's just look at the first transformation, two space to two space, and its inverse. What we're saying here is we have four graphs, and we are recording all the slopes in all these four graphs. X is a function of S, and X is a function of T. So the partial derivatives are just Calc 1 derivatives. Y is a function of S, Y is a function of T. All my partial derivatives are my slopes in these respective planes, just Calc 1. When I flip the axes, that's the inverse function, the graph of the inverse function. And their slopes are just the reciprocals of our previous slope. Change in S with X is 1 over. That's just the reciprocal because we just flipped axes. And I just record that information in our matrix. So the components are all reciprocals of the components of dt. We're going to be using the transpose matrix when we rephrase things as operators. And now let's set up just the first component of our transformation. So we have our R2 to R2, and then the first component of the S transformation. Well, second component, I guess. It's a function of xy, or it's a function of st. And it could be a function of xy through either z or u, and it could be a function of st through either u or z. So dv as an operator, it's the partial acting on the scale v. Differentiation of transformations, the slope numbers is this matrix multiplication. Vx is a slope number, Vy is a slope number. Or instead, I'm going to think about it as an operator acting on the function z. Thinking about it as an operator to get the exact same number out for v sub x, it's looking at the inverse transpose instead of just the inverse. The same works with S and T. As an operator acting on Z, or looking at those two slope numbers, ZS and ZT, it's just the composition of those two matrices. If I flip around as an operator, it's the transpose. So the function path again, we're taking ST going to XY going to V.